Perfect. All right. Thanks, everyone, for joining us this evening. We're joining James Bourget and Geoff Kirkpatrick at their Kootenay Building Science Studio in Meadow Creek to do a bit of a virtual lab to get a better understanding of some building science fundamentals. James, did you want to introduce yourself and then I can introduce the session?
Yeah. Hi, everybody, and glad you could join us. And we'll have 2 hours that should be fairly fast-paced. I tend to go off on tangents sometimes. I'll try to stay on track. But I'm principal at RDH Building Science. I've been there for quite some time. I spent a lot of time education focused on different assembly types. And right now we're focusing on moving forward with higher performance assemblies and trying to think about how do you build these R25, R30, R35 type walls rather than the straight up 2x6 wall assembly. We're going to look at that today using some mock-ups to demonstrate some of the building science fundamentals, some practical structure methods, and some common building materials. And we're just going to do things just a little bit differently, okay? Geoff's going to introduce himself, and once he finishes his introduction, he's going to do a little pan shot to show what's behind you here in our little playground of building science and mock-ups, okay?
Good evening, everybody. I hope you can hear me all that well. My name is Geoff Kirkpatrick. I'm a local energy advisor and previous partnership with James at RDH Building Science. This is our Meadow Creek lab. Are we on the camera line?
Yeah, I'll put your camera line over. I got to stop my share and I'll move you right on over to that one.
You can see here we've got our window mock-up that we're going to be working through this evening. We have our roof to wall transition with renewable details, which will be showing you the intricacies of our penetration wall, showing multiple penetrations through an exterior air barrier assembly and the air tightness stuff. And our test chamber, it's going to give us a smoke and a pressure test. We're going to mount to these bucks that we see here today and do a pressure test of each unit. Back to you, James.
Okay, thanks, Geoff. Yeah, so you get a sense of what we're going to do today. So I'm going to share my screen and put you back on the presentation mode. And I'll put you back on the main camera mode, and we're back to where we started. I trust everybody can see that. Jenna, you give me a thumb. Everybody's okay?
Yeah, we can see that. Thank you.
Thank you kindly. Let's move on. I'm gonna turn this now over to you, Jenna, because CEA is going to give you a few words, recognize Indigenous peoples, etc., as well as what CEA does for the province.
Thanks, James. So hi, everyone. My name is Jenna. I am a Built Environment Initiatives Coordinator with the Community Energy Association. We'll just next slide there, please, James. Yep. So I'd just like to start off by acknowledging that the Community Energy Association, we acknowledge that we carry out our work on the traditional and ancestral territories of Indigenous peoples. So through our commitment to truth and reconciliation, we support First Nations, Inuit, and Métis communities in taking climate action and reaching their goals of energy sovereignty, security, and resilience. So I'd just like to begin our session today by acknowledging the Indigenous peoples from all of the diverse and beautiful places we are joining from. I know we have a lot of folks from across BC. So I'm joining from what is now known as Nelson, but for thousands of years has been the traditional homeland of the Snakes Nation, the Silks Nation, and the Ktunaxa Nation, and is home to the Métis and many diverse Indigenous peoples. So I just like to acknowledge with deep respect and gratitude that it is in thanks to their generations of stewardship that we're able to enjoy these mountains, forests, and waters in the way that we do.
Thank you, Jenna.
Perfect. So the Community Energy Association, who are we? CEA is a registered charity and nonprofit. We're committed to accelerating bold action by local governments and Indigenous communities related to climate and energy. So we have an unwavering commitment to our clients to provide services and support on the journey from awareness to plans through to implementation. So what does that have to do with providing education for the building industry? Well, in BC, buildings are the second largest source of greenhouse gas emissions. So building better is climate action. In all of our workshops and webinars, we are product agnostic and we bring in speakers who are top of their industry. So CEA is committed to providing educational opportunities to everyone, regardless of their existing knowledge or experience. So it's really important to us that we provide a safe and open space for attendees to engage and participate. So please don't hesitate to ask any questions you have. We're happy to address them. And then just the next slide there. Perfect. So the Kootenay Clean Energy Transition. KSET is a project that was developed to address shifts happening in the energy efficiency, renewable energy, and home comfort space. So through KSET, we want to help Kootenay and boundary communities prepare for a more energy efficient and healthy future through training and capacity building sessions like this one. So thanks to the generous support of the organizations you see listed on the bottom of the slide there, we're able to offer this free workshop as part of that capacity building piece. We do have an incredible amount of workshops and webinars planned for this year. So you can see the full list of events we have planned at the website at the bottom of the screen there. So communityenergy.ca/built-environment. All right, so tonight's session is a bit of a twist on a webinar. We're trying to bring you real-world applications and demonstrations virtually. So with that, James and Geoff are going to be changing cameras and microphones, as you just saw. And as they move between presentation and display, if you have any difficulty hearing them, just let us know, and we'll just make sure that we have the right microphone on. The session is broken into 3 main parts, and there'll be an opportunity for questions after each one. So feel free to put your questions in the chat, and I'll read them aloud at the appropriate time. Or when it comes to that discussion piece, you can go ahead and put your hand up and we'll call on you to unmute yourself. For the registered builders on the call looking for CPD points, we will be sending out an email confirming your participation to all of those who joined us for the full duration of tonight's webinar. We're also recording the session, as you would have seen when you logged on, and we'll provide that link to the recording for all of those who registered for the event. And that's it. I'll pass things back over to you, James.
Thank you, Jenna. I got to read my legalese, which require materials intended to be used for reference, continuing education, and training purposes only. Neither RDH Building Science nor the persons presenting the material make any representation of warranty of any kind, express or implied, with regard to whether the material is appropriate for or applies to any specific project, circumstance, or condition. You have to take each one on its own merit. This is about the fundamentals. Applicable and current laws, codes, and regulations, standards, and policies, as well as project and site-specific conditions, procedures, and circumstances must always be considered when applying information, details, techniques, practices, and procedures described in this material. All right, so moving on from there, got that done. Let's get into the presentation. We're looking at building science fundamentals and practical construction methods, okay? And it's about high performance enclosure assemblies, and there's lots of talk about that and what is that, but from my experience, and I spent many decades out there along with Geoff, it's not difficult. It's only a bit different. We have to look at things a little bit differently. We have to use the fundamentals of building science, the application of physics to environmental separation by climate zone in order to build appropriately that will stand the test of durability. And with this webinar today, we're going to look at constructability and renewable detailing. And what is renewable detailing? Well, if we build a high performance assembly and let's say we happen to put 4 inches of insulation on the outside, how are you going to change? Oh, I don't know. How about your roof shingles? How about your deck membranes, etc.? So we're going to look at that kind of approach and how that can be achieved quite simply. British Columbia climate zone map. Many may be familiar with it, some not so much, based on heating degree days below 18 degrees. And what that kind of says is it's not the same everywhere. And so maybe you have to build accordingly to deal with the different exterior environments, varying interior environments. Not every home has the same interior environment. Okay, building enclosure requirement climate zone is a healthy way to look at that. And we're dealing with environmental separation. And, you talk about even things like water load. Is that only rain and melting snow and ice damming that? Well, there's also a water load from the inside. So you have to look at things quite holistically. What is the building enclosure? Well, as you can see here on the little graphic, it's a place where you are, or we are, and the environment outside is where the world is. So separating you from the outside environment, keeping warm air in, hopefully, keeping cold air out, hopefully. And its performance pretty much depends on the materials used, okay, and how well it's designed and constructed. And moving forward, we start really trying to conserve that energy, okay? we need to be aware of how it is constructed by climate zone. So there are some environmental loads: water, air, heat, vapor, and there's some critical barriers: water shedding, water resistive, air, thermal, and vapor controls, okay? And these things team together, but they all have a relationship, either directly or indirectly. And you can see that the air barrier, well, directly relates to air. But interestingly, the air barrier also relates to your heat or thermal, your vapor, and your water. It has a relationship with all the environmental loads one way or another, and we'll try to get into some of that, okay? Then you look at the next in the line when you talk about enclosure first. You want to make some air tightness, and you want to improve the insulative value or thermal improvements. Well, the insulation obviously has a direct relationship with the heat, indirect with the vapor, and with the water, okay? And so it's affecting quite a few environmental loads. Something like the vapor retarder, well, it's dealing with vapor. You see, just that's what it's dealing with. And then the water resistive barrier and the water shedding surface clearly deal with water. When you take all of this away and you look at what's remaining, it's the air barrier system that really provides you tremendous benefit. It is one of the things that's going to greatly reduce your energy demand to a very significant level. And it's also going to be very, very important on the performance of your environmental separator or your building enclosure. We want to keep a handle. We want to limit the amount of uncontrolled air leakage. We want to manage our air leakage controlled. That's your ventilation system. So I want to be clear. The air barrier has nothing to do with how your house breathes, okay? The air barrier, what we talk about here when we talk about air leakage, is uncontrolled air leakage through the environmental separator, which you don't want. So you can now manage your mechanical. And each thing ties to each other, which we'll try to expand on as we go along here. So the environmental loads and the 5 critical barriers. So you start looking at this. Here's a typical wall assembly. This one here is interesting in that you see there's a little bit of insulation inside the wall, and there's a little bit of insulation outside the wall. Some things you would need to consider is what type of insulation is outside the wall. Is it vapor closed, vapor open? These are things that we'll try to talk to in this webinar too. Try to remember too that over 2 hours, and what we're looking at in the assemblies is we can't go too deep into all the aspects of building science. Hopefully I'll leave you with some things to make you go, things to think about, things to further look up, maybe things to check out on future webinars, stuff like that, where we can take a deeper dive on specific topics. I'm going to try to stay quite general on the building science aspects and dig more into the mock-ups that were constructed and how that relates. But you notice one thing that's here that's interesting, that with all the educational events that I attend and builder trainings, etc., that I'm often amazed at the confusion between vapor barrier and that you have to tape and seal your vapor barrier. Well, you don't have to tape and seal your vapor barrier, but you need to tape and seal your air barrier. And so by default, the vapor barrier can also be an air barrier system if it is continuous and sealed. And that's what's been happening by default. All of this, the blue tape and the poly, sealing all the light penetration, everything. By default, even the upper ceiling plane of a vented attic, that's polyethylene up there with all the poly plates from bedroom to bathroom, all that upper floor air, plane of air tightness. That's all done by the poly by default. There are other ways to do it, and this graphic shows an exterior air barrier system. That's what we're going to look at. We're going to look at putting the air barrier on the outside. It's simpler. The results have been tremendous, and there's some tricks to do to get good air tightness. Is recognize your transitions and interfaces, make a reasonable effort to address them, and based on an air changes per hour, a volume-based metric, the builders that I'm working with and have worked with and call me up and we chit-chat, they're all getting under 1 ACH. There's not a problem doing that. The key is just recognizing where are the leakage paths and making a reasonable effort to address them. So that's all I'm going to do on building science. You need to know that there are some environmental loads. There is an inside environment and there's an outside environment. And you want to manage these environmental loads and try to maintain human comfort. Okay? Let's look at a window penetration. This is a window penetration, and I call it a penetration because it is a penetration. It's penetrating. There's a hole in your wall, and it's filled up with a window. we're going to look at today, the wall that we have built in the mock-up is a 2x4 frame wall with 4 inches of exterior mineral wall. It's about an R28 wall. Okay, now I'm not going to dive into the full analysis. It's for discussion purposes. Okay, and it started, as you can see on the left here, it started with an exterior air barrier. You can see that the window opening is prepared. All the laps are taped and sealed. This is an exterior air barrier, and a window will go inside and it'll be connected to that by way of sealant and backer rod. The part that gets interesting now is we're going to look at the insulation part. And, this is called a pre-strip. And this is the idea that you're framing a home or residence or whatever you are. You're going to strip in your window with paper, sheeting membrane of some kind that's going to serve as your water-resistant barrier. We're going to also tape it and make it the air barrier. And we're going to put the window inside there. And so we're going to try to bring the building up to lockup. We're going to do the doors, the windows, put the roof on it, be able to lock the building up. Okay. Well, at the same time that you're doing this paper, you can also do an insulation pre-strip. And so what that means is you can start to split things up and diversify a little bit. And we'll get into that a little bit. That I have installed here with Geoff, we have installed the insulation starters. We haven't put the window in yet. Yes, you can do that. So at the same time that you strip in the window, you can also strip in with insulation. It has no effect on your install. But it does something very interesting, and we'll get into it and you'll see how it unfolds. But if you see on the third picture that we have shown this cutaway here to show some of the inner workings, okay, because it's a mock-up for education. But what you can see here is we have an adjacent wall area that only has window stripping, but we're able to completely finish the entire window and trim detailing to receive the cladding. In this case, it's a fiber cement with wood trim around the window with dadoed backside to slip the siding into. But we're able to finish all of that before anything else was done. That provides you some interesting options, which I'll talk about. Some of the considerations, so the window penetration detailing. With the mock-up, we used a high-performance flangeless window. And we had that same, as I mentioned, a split insulated 2x4 wall, R10 in and R16 out, roughly. Okay, but we want to think about our window placement and trying to get that somewhere in a central location of our thermal plane. Well, with a 2x4 wall and 4 inches on the outside, that happens almost by default. That placing the window in the center is kind of automatic, and it's quite beneficial. There's also a benefit to having a 2x4 interior wall versus 2x6. See, the 2x4 wall is generally all that's needed for structural purposes. I spent quite a bit of time when I had a full head of hair and all this other stuff, and we were building out a 2x4. We changed to 2x6 to address some of the thermal requirements of getting an R16 wall assembly. It wasn't about helping the home stand up. Sometimes you need a 2x6 wall or a service wall or whatever, shear wall, whatever. Doesn't matter. But 2x4 framing is generally adequate. One of the things that when you do a 2x4 wall and you put, for example, 4 inches on the outside, that you actually maintain a sheathing temperature even under, for example, a minus 15 design temperature. That sheathing will be floating somewhere around 4 degrees. That's pretty good for reducing condensation for any kind of interior air that may contact that sheathing. Because if we're honest, we know that air leakage is not zero. We know that there will be some potential condensation if that sheathing is cold, but by putting insulation on the outside, we warm it up. So we're working on that premise moving forward, that I can get a very, very good wall with 2 simple layers of insulation on the outside. And we'll show you how that was put together and how incredibly simple it really is. But again, it's the penetration starter system, okay? If you're going to do and strip in around your window, start with a 24-inch wide starter strip. So I take the big roll. I'll do, for example, let's just take Tyvek because everybody knows Tyvek and we can just talk about it, okay? I'm not endorsing Tyvek or anything else, any other product or membrane. I'm endorsing the principles of vapor open insulation, vapor permeable sheathing membrane, water resistant membrane, okay? That's how it is coming from, is I can take my roll of Tyvek and I can put it in the chop saw and I can chop it. I chop it to 24 inches. So now I have this 24-inch roll. It's my starter roll. Everything I strip in, vents, hose bibs, windows, I just use the same starter roll. What that does, that little extra width, is typically I was doing it with 18 before. I do it with 24 now. So I can put my insulation starters on top of that paper and have enough sticking out past it so that I can tie in my field membrane later. Okay, sounds pretty simple. The part that's really quite fun, and I've worked with builders and had a lot of fun with, is when I say to them, if you know the rough opening size, you can prepare all your window strip-in membranes, including the cellular membrane, and you can prepare all of your insulation starters ahead of time if you know the rough opening size, okay? And basically, I'm saying that, and this comes from this right here. Here's how it works. So many times people say, hey, James, can we use those pre-manufactured corners and stuff like that for the windows? If you want to. Sometimes they're challenging to maintain air tightness, and sometimes the framing is not perfectly square. But what if I told you that you could pre-make your own and install them at your own will? So one simple roll of membrane, you can pre-make all of your corners and pieces so that you can just bring it to site, already made, and install them. The reason I like that is, and I've done this where the builders, obviously nobody believes you. Oh yeah, sure you can. Okay, give me the rough opening cut sheet, okay? So I'll put it in a box, put them all together with an elastic band and label it, bring it to site, put it in front of each window, open it up, install all the pieces for that window. And so if you take a junior staff, whomever that might be, he or she, no matter whom, somebody that doesn't know how to install window strip-ins, and you take these pre-made pieces, all designed very simply to fit, and they do 2-3 windows. By osmosis, they're going to have the education of how to do that. It's just osmotic learning. And you think, what the heck is osmotic learning? Osmotic learning is how we learn to do everything we already do. Right? We see it done and we learn how to do it. All the times I spent working in construction, and I didn't go to school for everything that I know, but I learned it over trial and error. And then you learn it. Well, you can do the same thing with the papers, the insulations, and all of a sudden you got a very high quality install at a fraction of the time, very little waste, and limited site time. You don't want to build everything on site. It's not the most conducive place. If I could build it at a cut table in my shop and bring it to site prepared, yeah, I think a lot for that one. And so I'm looking at this and the sequence of construction. I showed you and gave you a hint. We had that 3 photographs. I showed you the windows already finished, but the rest of the wall wasn't. So could I split my crews up and have my windows done by skilled tradespeople that need to do the finicky work? And could I get the walls filled in by more of a production-based type crew? Absolutely. Can we blanket across there in a unified manner? Absolutely. It's done all the time. But it's a little bit different way of looking at things. That's what works for the sequence of construction. So I'm going to look at the window penetration exterior air barrier. That's what we're doing, okay? And the flangeless window that put in for this mock-up, okay? And I'm not endorsing anybody's windows or anything of that nature. I'm just saying this window uses a back angle, okay? And it's just an aluminum angle, okay? 1.25 high by 1.25. And that's how the fixation along the sill is done for that window. It also provides a tremendously lovely water stop, and it's high enough based on simple design pressures that even if there was a fail in the air seal, it won't result in water ingress, okay? But that's where the air seal goes against that angle and around the window in line with that, which we'll talk about, okay? So I wanted to point out the aluminum back angle. And the first thing you do, and I see this whole time as I'm driving along, and well, I have no life, and I look at buildings under construction and I say, well, I try to guess what the air barrier is, right? And so I'm driving along there and I see all this Tyvek or Henry or whomever on the outside, vapor seal, tie part. It doesn't matter. Please know I'm not endorsing anybody. I just use it for familiarity purposes. And I see it, all the vertical joints are taped. So, well, that's poly air barrier because you need to tape all the joints. But if I see all the joints are taped, that's great. Then they're trying to do an exterior air barrier. Then I see the gable wall is taped all the way up to the top, but it's a vented attic, so they kind of messed it up because you'd have to transition at the seating plane there. And so you start to see all these neat things once you become familiar with that process. And so right now, when you think in your mind, say, hey, I'm going to put the sill membrane on a window, people will take the sill membrane and go right to the sill of the window install a sill membrane. Okay, it seems reasonable. I'm suggesting I start 7 inches above, and there's a reason for that. I need to lap 4 inches. I got an angle. I'm going to put some tape on there. I don't want the tape that I make in my air barrier to interfere with my drainage plan. I want free drainage at the corners. You know that windows drain at each corner, right? If anybody ever taken a building apart or anyone that's a bit deteriorated, it's always the corner and the corner that's deteriorated. By default, water that gets on the head of the window or through the jambs comes down and drains out the corners, all right? And so I brought this and I start with it 7 inches above, okay? So I'm installing a sill membrane 7 inches above. That allows me, I can lap my jamb membrane and stay off my sill so I can tape it and make it airtight, watertight, without having to muck about with it, okay? Next, I'm going to put on my self-adhered membrane. So I put on a sill and I'm going to put on my pocket, gusset, and jamb, okay? And at that point there, in a little bit here, I'll get Geoff, who's here with me, is going to show you that. And I'm going to show you a schematic of what these entail. Geoff's going to do a little mock-up on a table behind me here, and I'll just switch the camera view, and we'll go in behind, and Geoff's going to make, what's a pocket? Well, someone to put your hand in, right? No, a pocket is something that you're going to put in the corner, because you got to imagine that you have an angle here. You've got an X, Y, and Z axis here, and you need to try to put a membrane in 3 directions without cutting it. Very simple to do, basic origami. Okay, you're not going to make a swan or anything out of paper, okay? This is going to be quite simple. We're going to make a dog here, all right? And then once you get up to that point, you get that on here, you move over and you put the membrane on the sill. All right, so now you've got your sill membrane and you've got your self-adhered waterproof membrane on the horizontal part of the window that's required, okay? Once you got that done, you can start working on the jamb membranes. So you put the jamb membranes on here and you're going to lap it 4 inches over the self-adhered. There's the self-adhered. Lap it 4 inches over and extend it 4 inches above. Please note that all your cuts are vertical on a window, okay? When you're doing an exterior air barrier strip in, all the cuts are vertical. See this membrane that I cut right here, that wraps around the corner, but I cut it right here. So now it extends underneath here for 4 inches and extends underneath here for 4 inches, because you build the envelope from the bottom up. And so that's just what you do. Pretty simple. What I see on sites a lot of time is the jamb membrane goes on and it gets horizontally cut so it can wrap around a corner. Then the head membrane goes on and it gets vertically cut. So when you cut horizontal one and vertical the other, there's no overlap. I don't know, maybe you guys see this, maybe you don't. I see it on, I don't know, project after project, that I look up at the jamb and head interface and I see a line of wood because there's no overlap of the membrane. It doesn't make a lot of sense. It's pretty straightforward. This is a window penetration exterior air barrier. This is the pocket, gusset, and jamb. What I'm going to do right now is I'm going to stop sharing my screen. I'm going to put Geoff up on the mock-up table. I'm going to switch the camera angle over, okay? And then we're going to have a look, and Geoff's going to make a couple things, and I'm going to talk to you. Here we are at the mock-up table, and Geoff, go ahead. We can start our installs, and we start our installs with a pocket, okay? And so typically a pocket is 4 inches wide, all right? And the reason for that is the peel stick laps are 2 inches, and this pocket would come along the horizontal and vertical, so 2 inches up and 2 inches across. That's why it's 4 inches wide. The actual width of roll that you choose for your self-adhered membrane is a function of where that back angle is, okay? And for the purposes of this mock-up and the type of window that I'm using, I've set the back angle at 2.5 inches inboard of the face of the exterior sheathing. So when you think about this, if you have something that or similar, but let's just go through the mental math of what we've done here in the studio, is if I put the angle 2.5 inches back, and my angle is 1.25 inches tall, in my mind, my simple little mind, I say the angle part, I allow for 2 inches. Then I say, I have 2.5 inches across my sill, that's 4.5. And the minimum lap for my peel stick is 2 inches. Therefore, I got a total of 6.5 inches. What is the width of those rolls? Well, I'll be 6.5 inches. So it seems to work out just fine. Now, if I had a window type and I changed where I'm going to place it within that thermal plane, a little bit this way, a little bit that way, I'm still trying to stay somewhere in the central zone of my thermal plane, I can choose a membrane width that suits. That's not the only width available. It's not the only type available. It's just a consideration. You want to choose everything that works together so that you can be efficient. So what we're going to do right now, Jeff's going to make a pocket, okay? And Jeff, I'm going to let you explain the 2x2 and the left side and the right side. You'll see right here on the screen there. Jeff, you want to point your little window mock-up there? So we got a window mock-up. Jeff's going to just place it on there, okay? So when you look at the graphic that you can be provided on the slideshow, you're going to look at it and go, holy doodle, what is this? Well, this is a chance now you get to see how that works. So Jeff, go ahead.
See marked out on the front face of this piece, we have our 2-inch across on a 4-inch piece. I've marked out 2-inch as well from my fold. This will end up being that component that sits inside the pocket. So I'm going to cut it on the reverse side. As you can see, I've marked the front side. Now I've marked the reverse side of my 2x2 cutout. And then which way I'm going this way. In this case, I'm going to use it my knife. I'm not cutting the membrane. I'm only cutting the backing. Just a light
Or using the backside for scoring. Isn't that another way you can do it?
Yeah. You're just scoring off. All I want to do is remove this portion of the backing. And then I'm going to take these two edges, line them up for that dog ear, press them together. Here comes the magic. I invert, and I now have my inboard pocket.
We'll place that in the window. What does that look like?
Here we go, into the window opening, using my paddle tool to intimate pressing into the interior tube transitions. And there is my inboard pocket.
Where does the dog's ear go when you install that?
Up against the jamb.
Okay.
So I can wrap it in with the rest of my assembly.
All right, so all the cuts are vertical, so which way do I make my cuts?
I'm going to cut my back vertical for a fold down.
Yeah.
And I'm going to cut my front also vertical up the jamb. So I have a receiver tab for my jamb piece.
So you can pull that right back up into a little package, eh?
Yeah.
So if you have to remake them.
These off, I had a box of them folded up in a box, ready to go.
You can label it and you're good to go.
Left, that's my left pocket done. And in the installation process, obviously I'm going to peel my backing to the first transition.
One plane at a time. You stick one plane at a time. Remember, this has got primer on it, okay? In real life, we're not doing that here on the webinar. No.
So by anchoring that, I can now pull out the remainder. Press in my transitions.
Notice how you do the axes, the X, Y, and Z axis first. Don't push it onto the wall and try to push it into the inside corners. That's backwards. Do the axes and the walls fall into place automatically, okay? Remember, the sill membrane will be installed. We're only showing you the peel and stick and what that means on that graphic, okay? So how do you make the gusset and the actual jamb piece, Jeff?
This I'm going to get 2 out of 1 in this case. So the glare is a little bit much, but you can see I've marked out this piece. It's a 7x9 in order to bridge my 5-inch return, my returns, as well as my 7-inch return on the side. So it's going to give me 2 out of 1. I've marked out my 2-inch return vertically. You can see here, I've marked out my 2-inch cutout. That's going to be my step going over my jamb section. These are going to tie together. So as we cut this out, I'm going to cut my front tab, return to the inside of the jamb. I'm going to save this piece. I'm going to cut my vertical, which I've already marked out here.
That was 2.5 inches in, right?
This is 2.5 inches in. And then I've also marked my 1 1/4 return for my back angle. And before I install this piece, I'm going to take my remainder of that cutout, cut off the excess I don't need.
What size are they roughly? I think they're 2" by 3"
What
right?
I'm left with is a 2x3 piece. And I don't know if you can see the markings on there, but this is my bow tie gusset. I'm going to cut this one out, going just slightly off center to one side, slightly off center to the other side. You can see I've now made 2 cuts. Remove these 2 pieces, and that's what I'm left with. 2 more small cuts on the corners to relieve the tension, because this is going to be installed under tension. And there's my bow tie, or that way.
Yeah.
I'm going to install this now on my installed pocket piece. Fold it in half, remove the backing paper, put it on my paddle. As you can see here, that fatter section is 1 inch in from the end. I'm going to project my gusset 1 inch out of the opening. Wait, see that?
Yeah.
Press it into that transition, up both sides. And with a little magic, I'm going to work this edge, covering that pinhole that's going to form in the corner there as this piece was cut out. So by working this down into a return, I now have 1 inch of coverage over top of that pinhole location in the corner. Pressed in, nice and flat. Now, that piece that we had cut, going to line up with my back angle, as you can see, and across the front of the windowsill. So I will start in the back corner, peeling off my backing paper. I'm going to line that up and install horizontally. Nice and straight. So what's on there, you can now remove the remainder of my backing paper. Transitioning down to my back angle, either side, across the front face. You give this a fold and a crease because I like nice clean edges to work with. Down and over top of my gusset. The last step is I'm going to trace out the edges of that gusset. I want to be able to see all those components. I want to plug off the little air ports that will happen as a result of transitioning over from one piece over top of another. You can see there, you've got a nice tight fit on that interior corner. Move a little closer here. You can see there, I traced out that gusset. You can see, work backwards here. On the inside, I've also traced out the return of the dog ear. You can see that dog ear return inside there. That's a very nice tight fit corner. I've covered myself with appropriate laps to give that transition strength.
Yeah. Thank you, Jeff. Bomber from Lucas Armstrong. Thanks, Lucas. All right. So what I'm going to do now is I'm going to come back to myself. And I'm going to share my screen again, put you back onto the presentation. That helps to clarify.
James, sorry, I'm just going to jump in here and just in case there are other folks who are having a hard time figuring out how to see the presentation and full screen when Jeff and James are doing their demonstrations. At the right hand corner, top right hand corner of your screen, there's a view option. And if you click on if you click on speaker view, then you'll be able to just see the demonstration there. And James, I'll give you a time check too. We have 15 minutes left on this piece.
Well, I don't mind run a little over. I have to maybe do something about that, but I'll do my best. Okay. Anyway, that clarifies this. Okay. I wanted to, because you'll see this and go, what is all this? Well, now you have an idea. So that's what we did. Is we had a look at a seal membrane demonstration, and thank you, Jeff. Okay. So now that we got past the sill membrane, we're going to install the membrane starter at the head. That's this piece here. Note that the cuts are indeed vertical. Note on the bottom, all membrane cuts are vertical. Both the self-adhered and the vapor open membrane, all the cuts are vertical. And that's the up and down vertical, not the horizontal vertical one that sometimes my class teases me about, okay? All right, so you install your tape, all the laps, and now you have an air barrier system, exterior air barrier system, okay? This is where it gets interesting. You start saying, okay, well, I put in an air barrier around the outside. Well, now I'm going to put in a starter of my thermal barrier. I'm going to do a thermal starter. I did a water and air starter. I'm going to do a thermal starter. And that starts off, you install the first insulation layer flush to the rough opening, okay? That's right here. And you put a 10-degree slope on the top and bottom, okay? Very simple to do. You can run any insulation through a table saw. That's exactly what we do, okay? That's where you're going to drain at your head and at your sill potentially. So you put a 10-degree slope on that, okay? That's your first layer. And you say, well, now let's put on a second layer. But you're going to say, well, what's that plywood on the top of my second layer? Well, somewhere along the line, you're going to have to put head flashing and various things above the head of the window. And the last thing I want to do is I don't want to put stuff through my insulation into my air barrier behind that I may need to adjust or play with. And sometimes you're doing flashing and stuff, and you got to make some adjustments in that. If I put a fastener through this, I don't want to take it out because I got a hole in my air barrier behind here. I don't want to take off my insulation. Well, that's a waste of time. But if I could take a plywood and I put what I call cribbing or backing in this area here, I can attach to this. So this cribbing or backing, call it what you will, is a 1/2-inch plywood. So what I've done is my starter on the second layer at the head is not 2-inch mineral wool, it's 1.5 inches. And I added a 1/2-inch plywood, so everything is all at 2 inches and lines up fine. So once I've got that settled up, I get my backer set up into there. And that's what I'm talking about here. I've reduced the second layer head by 1/2 inch. I can reduce it by 3/4 because mineral wool also makes 1.25 inches. But I just went with a 1/2 inch and 1/2 inch. Well, that's what I had in the studio. It was quite simple, okay? And then down here at the sill, you can see that on the first layer, nothing. The second layer, we have a membrane flashing tape. This is basically a nice tape that you can put down on top of your sill. So any water that happens will drain outboard of the insulation. This is quick. This is simple. This is only to direct water out, okay? You don't have to get all super concerned about that. But what you do want to wonder, and you got to wonder, is if you know anything about mineral wool, it's kind of like a fuzzy cat. And if you go to try to put tape on a cat, well, you might get clawed, but it also doesn't bond very well, okay? And so there's a simple way that you can make mineral wool ready for receiving a membrane. And that's by using the actual aerosolized primer and spray it and letting it flash off. So what happens is the mineral wool gets crunchy, just like my grandma's hair used to be. As a kid, I was always amazed. Grandma's hair was crunchy, and I always wanted to touch it because it was really crunchy. The same happens with the mineral wool, okay? So now you can drop a tape on there with no issue whatsoever. Offset your starters 2 inches. The thickness of the mineral wool itself is fine. Okay. I'm going to put me back on my screen and off we go. So now I got the plywood receiver here, and I got to put a sheathing membrane on it because even though not addressed verbatim in the building code, the mineral wool itself will actually function as your second plane of protection. I have tested these ad nauseum on other places where I've had the privilege to work and teach. And it's extremely hydrophobic, the mineral wool or any insulation type. And when you stagger your joints on 2 layers, you can't imagine water getting to this point. Any water that gets through your rain screen or your cladding assembly is going to run down the mineral wool. And you think to yourself, well, how is the mineral wool for water? Well, I'm going to stop for 1 second here. I'm going to stop my share. I'm going to push you back over to Geoff, okay? And he's just going to give you a 2-second look at, okay, here's a piece of mineral wool. Bring that up to the camera. It's like mercury. It's like ball bearings on the mineral wool, okay? That's pretty impressive. So imagine you have that on the outside of your wall. I think we're feeling pretty good. Thanks, Geoff. He's going to dry it up now, see? Oh, yeah. It's also flame resistant. Just saying some things I like about it, okay? Thanks, Geoff. All right, go back to my share. All right, so that's why I have the tail coming down 2 inches. It'll function as part of my water resistant barrier. Then I look at the other side. I've got my flashing tape. I'm going to drop a sealant on that back angle because I'm going to push a window into that. That's going to make my air seal. And because I got my tape coming up on my mineral wool, I just carried the sealant along here to help hold it down. This was just me being me, okay? Not the end of the world. You can see the red primer. That right there, the mineral wool's crunchy right there. And that's why everything sticks real good. All right, so we're going to install the window shims, and we're going to do a flanges window, okay? So everybody knows you put the window shims on, line them up with the mullions. Any spacing in between here will be a function of the window manufacturer requirements, usually in line with the setting blocks of the window, but there will be a requirement, but you must have them under the mullions to carry the loads down through the structure. Flanges windows, they use clips, okay? And what that means is right here, and right here, there's some clips that are attached to the wall, and you need to seal behind those clips so you don't get air leakage behind the clips. You're going to seal in front of them, but you also got to seal behind them. This is one of the most common failure points that I see on projects when I'll do a water air test, that you'll get blow by at the shoulders here because the sealant behind the clip wasn't done well, okay? Once you get that done well, then you can put the backer rod between the clips, okay? And now you're ready to install sealant all the way around that window, okay? So you got that set up. You've got the air seal. Remember, the air seal for any window, a door, fenestration is always on the interior, okay? Not on the outside. It's supposed to drain. So you look at this vapor barrier or vapor control and bat installation. Well, this was our 2x4 wall, so we installed that. Okay, so we installed the bat and vapor control. But you see the note on the bottom says, vapor control only needs to be taped and sealed if serving as part of an interior air barrier system. So we've taped and sealed this here out the window because we had brought our Tyvek to the full depth of the opening. So we taped it together. So in essence, we can have 2 air barriers. Can you have 2 air barriers on a project? Absolutely. No problem. 2 vapor barriers? Absolutely not. 2 air barriers? Absolutely so. Okay? There's not, one's a so and one's a not. Okay? And so if you're going to do that and put an air barrier, then you need to look at taping and sealing your connections to the floor, to the windows, penetrations. It's quite tricky when you think about bathtub staircases and all this stuff and all the amount of inside receptacles you have that you got to get airtight. It can be challenging, okay? Well, once you got all that sorted out, you can look at installing your strappings. I use a 3-inch by 3/4 PT, bore 8 typically because it's friendly for fasteners. It's quite good for longevity in a rain screen cavity, but it's also 3 inches wide. So the code does mention about 80% net free area. 1x4 doesn't meet that. If you strap a 1x4 16-inch on center, you're about 78 and change with respect to net free area. If I do 3-inch plywood, not only can it take the linear fastening, it'll give me about 81.25% net free area, which is excellent. It's also a nice wide enough seat on in a mineral wool or any of the insulations for attachment purposes, okay? Now you look at thermal continuity at the window and you put a window in there, but you got this big old gap between the window and the framing. Well, that's kind of silly. You got insulation everywhere except there. Well, no, we have insulation there. And so what we do is Geoff and I would take a little bit of this here mineral wool bat and a straight edge, and I'll measure up a width. I'll push down on that and I slice it off. I call it banana bread, but that's just me being silly. I said, I cut myself a bunch of slices of banana bread that's about 2 inches wide. And the reason I want to do that, and I'll show you, because I want to fill that in between the window all the way around because it's soft enough that I can just do this. But I provided thermal continuity, so the window is still able to do its singing and dancing that it does, raking, etc. But it won't transfer the loads across, but it's thermally continuous. And you think, well, how will it drain? Well, the mineral wool will drain. And when you put something of that kind of nature that's hydrophobic and not damaged by water, it'll weep at each corner anyway. And where do windows typically weep? At each corner anyway, okay? And what I do when I stuff this in, the window I chose is 4.5 inches wide. I'm putting in an air seal on the inside, and I'm going to put a 2 inches on the outside. You have to remember that I brought my window forward 2 inches. Part of my design. See, I brought the window forward 2 inches so I could put 2 inches of banana bread in between that 2-inch layer in the window. Okay, that kind of makes sense. Was it hard to do? Nope. Why do I want to do that? Well, the reason I want to do that is I want to have a capillary break between my air seal and my insulation in the event that I do get anything that comes inside here. It will fall right down the jamb or travel right along the head or whatever, and will weep out each of the corners down here. Yet I'm thermally continuous with my 2 inches of insulation that I put on the wall initially, which was flush to my rough opening. It also provides me backing, so when I do my rod and caulk for my trim, etc., my backer rod won't fall into the rough opening. It's already occupied on my thermal continuity. Window penetrations, we're looking at this. We're going to install the wood trim, the metal flashings. You can see the cribbing up here. You see the flashing is attached to the plywood. I have short fasteners into the plywood. Nothing more is going to penetrate my air barrier. My straps penetrate my air barrier, but they stay. They're done. They're for good. And that's a compression seal. One thing about insulation on the outside of your air barriers is it will actually make the building more tight. It's called a sandwich effect, okay? And so air barriers, Tyvek's airtight when you buy it, tape's airtight when you buy it. You give it to people on site, they put it on, and you get little bits of air leakage here and there. Well, if you put the insulation on there in a compressive manner, you actually improve the air tightness. So it's a great way to deal with the human factor, okay? And we're not perfect. None of us are perfect. If we were perfect, well, we wouldn't have any issues, would we? And so I'm at this point here, and I got a sill flashing there. Well, underneath, I put on my metal flashing, but underneath my sill right here, I have a ventilation mat. So what I have is a potential for condensation. I'm just providing an opportunity for airflow to dry that out. End of the world? No. It's just me showing you these are all products that are available. And ventilation mats are typically used for passive type metals or zincs and coppers, etc., that can suffer from an oxygen concentration cell. Basically, backside corrosion, okay? Not really applicable to the sheet metal. It's just good practice. If you don't do it, it's not the end of the world. Okay? Back on the slide. Okay, so the insulation starter approach, you can see here that the green denotes your insulation starters, okay? Bang. So if I put these on, okay, I can do everything associated with my window trim-wise, my one strap and my trim. I can do all this work before I do any of the adjacent field work. That's a bonus. That's a benefit. You can use that to your advantage. And I've worked with many that we've exercised that offer to diversify the crew, where a crew of 6 could be doing 3 different tasks, which are supplemental, instead of all working upon top of each other. All the work is independent. All right. So on a recap on the window penetration, the sealing membrane and cellular membrane starters can be pre-made based on the rough opening and the window placement depth. Okay. And so there's a simple rule of thumb for example, the sheathing membrane mechanically attached, stapled on a window. The jamb membrane is always 1 inch greater than the rough opening. Doesn't matter the size of the window. It's just a rule of thumb. If I cut a 24-inch wide starter like I suggested you do, okay, and I have a 2x6 wall with 1/2 inch plywood, my wall's 6 inches deep. I know that I'm going to the full depth of the wall, right? And so if it's 6 inches return and I have 24 inches, that means I got 18 inches coming out past if I install that. That means my head and sill paper are the rough opening plus 36 inches every time all day. So I've even built the home. I already know all the sizes. I just have it pre-made. I used to have my kids do that for me, okay? But then they wanted to raise, so I had to move on from them. That was expensive. So if exterior insulation is planned, to use 24-inch wide starters. It'll allow you enough room that you can get your membrane lap, obviously what I'm talking about, okay? They can be installed before or after the window. Doesn't matter. If you want to put the paper in the window, go ahead, if that's what your sequence is. But you do have the option that whoever's doing the paper, it could be the installation crew comes on and prepares all the windows, and then the window crew comes in after. So you got all of these options. Maybe it's the same crew. Don't know. Doesn't matter. It just means one's not reliant on the other. So what that does is you get some flexible construction sequencing and crew allocation options that you can look at, okay? So the window penetration discussion, we're at this stage here. Basically, this was the end result. You can have a completely completed window, 100% complete, okay? And it started with an exterior air barrier, started with vapor control and thermal, and an option of 2 air barriers if you want. An insulation starter to suit the rest of the field because I had 4 inches on the outside, and some strapping to end up there. So all that work was done. So that puts it out the window. Okay. Was there discussion? Chit-chats, anything?
We have a couple questions that have come
Excellent.
through the chat. And if anyone else on the call has any questions, feel free to put them in the chat or raise your hand and we'll ask you to unmute. Derek asks, what's the point of the aluminum angle if the window gets back a rod and caulked on the bottom?
So the point of the aluminum angle is the window manufacturer wants an aluminum angle as their means of a very secure sill fixation. Do you need aluminum angle with some windows? It was Daryl, was it? No, you don't. Can you just put the clip down? Of course you can, but you must make sure you seal beneath it. The purpose of the angle and then part of the driver for that, and there are some changes pending where you'll either have to have a water stop, whether it be a piece of wood, an angle, or whatever, or a slope sill, because the concern moving forward, as we become more litigious and concerned, and the insurance people and the rest of the planet, is getting water to come inside. You got to think about the only thing stopping water from that sill coming inside is the guy or girl, don't get me wrong, the person that installed that sealant and backer rod did an adequate job with the proper bonding legs, the center profile is adequate, and that the caulking choice was appropriate. Many times you're dealing with plastics and that, and you got to ask yourself which sealant bonds to plastic, okay? The thing that an angle can do for you is even if I did not put any sealant on that angle, you would likely not suffer from water ingress. That's all. It's just a requirement of this window manufacturer for this install. It also provided an opportunity to demonstrate how to make a three-dimensional pocket out of any membrane that had a release in the back. I can make the same pocket with a tape. Anything that has a release in the back, you can make a water tap pocket out of doing the same technique. That help?
Yeah, I hope so. Let us know, Derek, if you have a follow-up question. Wilson asks, won't you tear something by tracing out the outline of the gusset?
What's that?
Won't you tear something by tracing out the outline of the gusset?
No.
That was
no. What we use is, you can have a paddle. So this is called Easy Tack, okay? This is a paddle you can get at Home Depot or wherever, and it's for carpeting, okay? But at the end of the day, it's plastic. The thing about tracing that there, you have to ask yourself this question. You have a 40 mil membrane, and if you lap a 40 mil membrane over top of each other, you end up with a straw port right here. It does not form at 40 mils thick in a perfectly square on that lap. You end up with a straw port. Leakage is a result of many, many straws that add up to an effective leakage area, okay? The whole idea of peel stick is to be intimate to the substrate, and the only way that can be at that lap is to run your paddle along that line, okay? And that's all that was. The other benefit of that is, and from my perspective as working as a consultant, and I do field review and attend sites, is that if I walk on site and I can see everything that was installed because it has been actually installed properly, and it transposes itself through. The whole idea of peel stick is not peel and float. I have been to projects where the peel stick is stapled to the sill, and I can only assume that it said P and S membrane, and somebody thought it was peel and staple. I don't know what that's supposed to mean or what I'm supposed to think, but it's supposed to be intimate to the substrate, and the only way that can be real is I would see it come through, and you won't tear it. They're quite resilient polyethylene phasers. Even the one we use is aluminum and polyphaser. Everybody's favorite, blue skin. You still got a polyethylene facer. You're not going to tear it. If you're tearing it, you're using the wrong tool and the wrong technique. You don't have to push that hard.
Great. Thanks, Wilson. Let us know if that answered your question or if you have a follow-up. Those are the only questions I see come through the chat. Are there any other questions around the window penetration? I think we're going to do a smoke test after this.
Yeah. Okay. So what I'm going to do here, everybody's back to the screen, I assume. We're going to look at this window. Pardon?
Sorry, yeah, we see your presentation there.
Okay, so this window that's right here right now, it's not completed because it's layered back, but the air seal is completed. The caulk is installed on the backside. What we're going to do right now is Geoff in the back there is going to boogie woogie. He's going to grab the smoke chamber, okay, because we built a mobile pressurized smoke chamber. So basically, we can put a pressure differential across this specimen, i.e. the window, or any other mock-up that we build, because we have a template for mock-ups and we build it on the same clampable base. So we can take this test chamber and stick it on any mock-up we build to air test it. For example, if I did a balcony PVC membrane insulation outside, I could test if that balcony interface was actually air and watertight. And I'm going to assume that if it doesn't have any smoke come through, it's probably watertight too. Okay, so what we're going to do, and Jeff's doing that right now, is he's going to clamp on, and I'm going to put the camera on. I'm going to stop sharing. I'm going to change the camera view, and I'm going to put you over there, and we're going to move around. We're going to have a look, see what Jeff's doing, okay? So this is the test chamber over there, and I will stop my share now. You guys now see the test chamber. Is that correct, Jenna?
We do.
Outstanding. Okay. And so at this point, you can see that there's a smoke machine busy inside here. Again, you can make these yourself. We just put this together on the weekend and said, okay, we're going to fill this thing up with smoke to a point where it gets to a point you can't see the window anymore. And then we're going to introduce the pressure differential, okay? And then we're going to look at the backside and see what we see. Okay? Are we getting tight? So, I don't know if you can hear, but you can see that. That's a bass drum. That's plenty tight. I'm going to spin around. I'm just going to slowly move the camera out of the way. If we can have a look at the back of the window. Can you spin it some more for me, Jeff? Okay. Well, you can see here, as I zoom into this window, you can see the sealant bead. You can see the sealant at the angle. You can see the smoke inside the window. But I don't see any smoke. So the polyethylene is not sealed around the outside or anything like that. It's just simply testing the window penetration. It is extremely airtight. And you'll find, and we found ourselves, that the test chamber itself stays quite firm for a very long time, suggesting that not only is the window airtight, so is our test chamber. And spin that back around. And again, this was simply done with still base drum. Again, simply using tie-bend, tape, and common materials installed with purpose, we can make an exceptionally airtight window installation. And you can pre-make all of your membranes, your self-adhered membranes, and all of these materials without any difficulty whatsoever. We're back to presentation and discussion. Any questions with respect to that other than, I know it's not very eventful because nothing happens. I should maybe just install one that leaks like crazy so we have something to talk about. Any questions?
I don't see any come through. So we'll move along because we have under an hour left in our session.
All right. So let's look at a slope roof to wall interface. This one here is a pet peeve of mine. I see this happening, and what I'm really happy to see is there are exterior installations going on today, but there's no consideration of, well, how am I going to change the asphalt shingles later? I see it come right down. They're a big project where I used to live. Townhouses, lots of townhouses. They had mineral wool on the outside. The vapor open insulation ran right down to the roof line. Then they had the hardy panel with the battens right down to the roof line. And I got to ask myself, and you can ask yourself, how are you going to change the shingles later? I am an RCBC approved inspector, and I sit on a technical committee, and I'm a registered roof observer with, and well, it's not a warrantable approach. Some say, well, I'm going to clone it. Well, that's not an appropriate way to get continuity of control. So at some point, what I find in my project, I have to open up lots of walls and to make them renewable after they weren't. And I'm suggesting that it can be done right from the start. And I'm suggesting that it needs to happen at the start as we move forward. Because if you start to put insulation on the outside, I hope you're separating your controls, and you'll understand what I mean as I get into this, okay? Again, I've broken it down in its phases. I have an exterior air barrier pre-strip, all right? That's the tie that you see in the back there, okay? And then I have my insulation curb with backing. Wow, gee, kind of just like the window, okay? And I have the cladding, in this case, fiber cement with a trim board at the roof-to-wall interface, okay? So let's see what that all means. So I look at this about the process of this renewable detailing and changing these shingles later, and you can start to see that I kind of put the shingles and everything on the outside of the controls. But where are the controls? Oh, I got vapor control and I got air and water resistant barrier on my wall. That was the Tyvek happening. I got thermal both into studs and outside, trying to keep that sheeting warm, reduce condensation potential. I got a water shedding surface, that's my cladding and my roofing just sheds the water off. And I got a water resistant barrier underneath my roofing and my underlayment. And I got it underneath my vertical on my plywood backing, and I got it on my wall. And it's continuous. That's what it needs to be. All your controls need to be continuous, okay? And so I start to look at this and say, okay, interface. What am I going to do? I'm going to do an insulation starter curve. I'm going to do my air and water resistant barrier strip in and my insulation strip in, starter curve. Again, I've reduced the thickness of one layer to add a plywood backing. So all of my apron flashing, my strapping, my wood trim, all of that is attached to my backing, not through my air barrier. Makes sense, okay? So here's a way of looking at it, just quick and simple. We're putting this together. I know I'm putting exterior insulation. I run my starter 18 inches above my roof, 6 inches below it, so I can tie in above and below. And then on the other side, that's my starter. On the other side, I keep the sheeting back 4 inches because that's the thickness of my insulation. I want my thermal barrier to go continuous too. I don't need to stick the insulation up that front because I'm moving the plywood forward. So I just keep it back, whatever. If I have 6 inches of insulation or 2 inches, I just keep it back the thickness of my insulation. Okay. And so now you see the plywood's on and we're back to where we started, where we have an insulation curb and backing right there. With this makes it equal at 2 inches and 2 inches. Okay, and it's 12 inches high. If you do this with a basic trim board, 5.5 inch trim board, you got to keep it 2 inches off the roof, way apart 9 for clearance. The 12-inch board works fine. So every roof's the same, yeah. You mean I just do this everywhere? Yeah. I can change them all later? Yeah. So, and then I got some infill in between whatever you've done to mount your jacks. I keep it thermally continuous, okay? I'll look at this here and I go, here's a view of the insulation starter with the plywood there that I showed you, and the first layer of adjacent insulation. Super. Here's a view of the insulation starter and a second layer of insulation. Note that the joints are staggered 2 inches minimum in all directions. That's what you need to do. Except at the top of the starter, it's at a 10-degree slope, just like the top of a window. You start to see that everything's kind of the same. You just do the same few things, and you can change all the detailing everywhere to work for you and make it quite friendly for renewability later. It's very constructible, and you can pre-make. Can I cut all these ahead of time? Yeah. That's what I had Geoff do. Geoff cut a bunch of insulation starter curves. I need some 8s, 10s, and some 8 3/4, 10-degree on the top. Comes back with a barn full of pieces, and we cut them to length, and shazam. Okay. Here's just a view on the underside. Okay, you see the insulation continuous. The second layer is installed. It's layered so you get a sense of what's going on. So I have continuous insulation underneath the roof. On the right-hand side here, I got my pre-strip and my flashings installed. Just the thing I'm getting at here now, it's exactly the same as we roof now. See, right now we have a sloped plywood deck and we have a plywood wall and we roof it. The only difference now is we got some insulation between the plywood on the wall. That's it. Doesn't make any difference, okay? To the install of the roofing, it's the same. But the benefits are huge, which you'll see hopefully as I move forward. So once you get this on, you can install your underlayment, shingles, apron, and you want to extend the underlayment up 8 inches up the plywood backing, 8 inches above the roof line. You know, everybody's heard that expression, right? Well, that's fair enough, okay? Once you got that on up to that height, you're going to install a counter underlayment counter flashing, which is going to take you from the top of the plywood backer and lap over top of your apron flashing. And apron flashing is this black flashing here. Black is just the color we had, but it laps over top. So everything's shingle. All right. Once you got that done, you can install your flashing membrane tape. Remember the primer on the mineral wool makes it receiver ready, and you bring that from the wall over top of the underlayment. So this is part of your water resistant barrier, laps over this water resistant barrier, shingles over the apron, heads out the water shedding surface, okay? Underneath it, right here, is a water resistant barrier, which is continuous because it's lapped. Do I need to tape it? No, it's a water resistant barrier, not an air barrier, okay? I come to this side, and now that I've got this done, I'm going to put plywood straps and bug screen. That's going to be where I'm going to mount my trim board. That is part of my renewable detail. And once I got that, I can continue with insulation on the wall, whatever your sequence of construction might be, okay? So I install the trim board on the plywood and the insect screen, on the strapping and insect screen. That's pretty simple. Then I say, I continue the strapping installation. All right, well, let me do that. So I put some strapping above. And now I can start looking at, okay, I can add my cladding, okay? I install flashing over the trim board. Now here's gets interesting, and I get this question quite often is, well, I install the flashing over the trim board, but my flashing is on top of my strapping. Well, I got to ask myself, do I want to run metal through my thermal barrier? The short answer is absolutely not. I would short circuit my thermal barrier. That's a Spock migraine. That's illogical, okay? So, but what I can say that if this is my drainage plane up here, it's good.
I think we lost him.
Okay, I was just going to ask, is that just me? Okay, let me send him. Oh, can you hear us, James?
I hear you. You hear me?
Oh, you're back. We lost you for a bit there, but you're back.
Do I need to rewind it?
Perfect.
Okay. Is that good? All right.
It was just about a minute.
You lost it for a minute?
Well, let's rewind a minute.
All right. All right. So I've installed and I continue my strapping. So what I've done is I have my water resistant barrier, my controls. My air and water is behind my insulation. My roofing is in front of my insulation, and I continue my strapping. I install my flashing over the trim board. And the function of this flashing is to keep the trim board clean and dry. It's a deflective element. It does not need to be integrated into my controls, okay? It's the only thing it's functioning is a water shedding surface. Any water that gets into the drain space comes out right underneath the board, 5.5 inches above. I'm not going to put two of them. I already have a flashing membrane running through my roof assembly, which I just showed right here. Okay, so any water that got behind this wall has a means to come out forward, even though there's a hydrophobic surface area in front of it. There's a number of redundancy that I'm still bringing it out forward, and that's to conform with the intent of the code, which doesn't exactly address everything that we need moving forward on high performance, and that's okay. You know, we'll all get there. So I install the flashing over the trim board, and then I look at, okay, well, let's put some fiber cement cladding on it. Say, okay, there's an interface. What am I going to do with that thing now if I need to change the shingles, okay? Well, I'm going to change the roof, and I'm not going to take off the cladding, and I'm not going to touch in my thermal, air, or water controls, and I can change this entire roof assembly. That's really quite cool, and Geoff's going to do that for you. What I'm going to give you is a little bit of something to think about here. That was the top half of the roof, okay? So I'm looking at the top half of the roof and okay, I got it. I see that plywood. I can take this board off. I can take that strap off. I can take that bug screen off, and I can see this whole area. It'll be right in my hands. Means I can take this roof right off. I can put a new roof right back on. I can replace my bug screen, straps, and board, and I've never touched anything. That's awesome because nobody's going to fasten through my air barrier. Nobody's going to touch any of my controls of my high performance structure 20 years from now when they go to change it. The last thing you want to do is have somebody change a renewable asset and damage the performance or lessen the performance of your structure. That doesn't make any sense whatsoever. And this is really quite simple to do. But underneath that is a vented wall. All right, you do not want to vent this wall into this soffit. So you're going to install some backing, okay? It stops it from venting up inside there, okay? And what you want to do is you want it to come venting out here. So there's a perforated insect screen. I use a perforated sheet metal. You can buy it, make it. It's very simple. Aluminum, galvanized, stainless steel, painted black, whatever. Okay, you can get whatever you like. And then what that is I get that installed, like show you here, and basically it vents out the front side. If I want to trim or I want to baffle it so you don't see it, I got many ways I can do this, okay? I left it visible, otherwise you wouldn't see anything, okay? So you can see that the wall would vent, come out this way where the air can temper, and if anything goes up inside, it's not direct hot air, because behind your wall, very hot, humid air, right? The ground could be wet, the sun could be on the cladding, it's going to be warm and humid behind it, and you don't want to put that up into your roof space. All right, so before we get into, well, we can get into discussion, but before we get into the discussion, okay, I'm going to stop now. I'm going to change the camera. We're going to have Geoff take this one apart, piece by piece, down to the shingle. We're not going to take all the shingles off, but he's going to demonstrate that you can simply change this roof, actually more simple than normal roof renewals, where I don't have to touch anything. I just take a trim board and a couple straps off, change the roof, put it back. Pretty amazing. And so with no further ado, I'm going to stop sharing. I'm going to move the camera over where Geoff is, and I'm going to drink water while Geoff yaks at you for a while, okay? Does that sound like a good plan? Sounds like a good plan. Do we see Geoff?
We do. Well, we see the, there's Geoff.
Our trim board, our roof membrane, pull the roof.
Sorry, we have a hard time hearing Geoff, James.
Geoff, they're not hearing you.
I'm yelling. On the trim board, to be any length. Pull my bug screen.
Can you hear now, Jenna?
Yeah, we can hear you.
Can you hear me now?
We can hear you. It sounds like it's still coming. You're just through your headphones there, James.
No, microphone is set on the camera.
You just talk.
Okay.
I'll just talk then, okay? So right now, what Geoff is doing, he's taking off the trim board, okay? Very simple. You can, if you don't know where the screws are, you can cut it off. It's a trim board. If you throw it in the garbage, doesn't matter. It's not big, nothing major in the roof renewal process. Now behind that was a bug screen and a couple of straps to make a rain screen trim board. So he's taken off the bug screen, taken off the straps. At this point now, he can lift up that counter flashing of roof underlayment, and you see the fasteners on the flashing. It's all designed that the fasteners aren't so high that you can't attach them, okay, detach them. And so he's going to take that off and remove that flashing. All right, so that was tucked in behind from the pocket from the end dam, and you can see now there's the underlayment. All we need to do now is take this underlayment, remove it from that point, right? Remove the entire shingle assembly. You can remove the metal flashings on the side. Everything that I showed you in the PowerPoint, none of it is interfaced with your cladding. None of it's interfaced with the air barrier of your building or the water resistant barrier of your wall or the thermal barrier of your split insulated wall assembly. When I'm done, I put the new shingles on. I attach my underlayment back in. You got a stapler there? Excellent. So we're going to put the underlayment back on. We got the counter flashing underlayment. We can put our apron flashing on. Standard roofing practice. Not too difficult at all. The thing that we've done differently is we have continuous insulation in an R28 wall out of a 2x4, and we will do absolutely zero damage to its integrity on a complete roof renewal. And so the closing is done. The counter flashing goes down, and the question, do I need to tape that membrane that he just counter flashed with? The answer is no. It is a water-resistant barrier. It's not part of the air barrier system. The air barrier system is behind the insulation of the wall. It never gets touched. And so now he's simply reinstating the trims, okay? And you can put them, when you put them back, you can put it anywhere you want. Just go ahead and put them on because you have plywood backing. And the fasteners don't penetrate. They go through the plywood into the insulation outer layer a little bit. No harm, no foul, okay? And so now you're putting your bug screen back on. That's pretty straightforward. And whether or not you save the board or you cut a new board, you take the trim board and you take it and you mount it back on the wall. And now you invoice the client and you get paid for a roof renewal, right? Pretty good deal, okay? That's looking at how you move forward, because you can imagine, okay? You know, all the silliness aside, okay? And silly but serious, I'll put it that way, okay? I like to have fun while we do this, but you think about it. If I didn't put the insulation on the plywood on front of the insulation, and let's say I had the roofing go behind the insulation, what would I do with my metal apron flashing? I would circumvent it. I'd have a massive thermal bridge, okay? If I put the closure on the outside of the insulation, I'd have to fasten through my insulation into my air barrier. So any way I do this, other than this, when you have exterior insulation, will be detrimental to the integrity of that assembly. And one of the things that was kind of, baseline for the building and the code and the rest is you can't make a building worse. You can make it equal or better when you get into these maintenance tasks. And as someone that functions as a roof consultant, I spend a lot of time working on large projects, city blocks of townhomes and that, where I have to do exactly this kind of detailing, but I have to start with the cladding already there, and I have to cut it, trim it, counter stitch it, and make it so next time in 20 years they do roof renewals, that they can actually do it effectively. The funny thing that happens is I do this on projects with RDH where I work, and a client come back later and say, our roofs look better than they did. We really like the idea that you came up with a trim and a way to enhance it. And it's really quite good. And I don't have any issue with my wall. I got the full warranty. It's fantastic. Do I have to do a wood trim? Then you do whatever you want, okay? If you don't want to put a trim and make it renewable, go ahead. I don't advise that. I don't think that would be prudent, okay? Moving forward for us and going to the net zero ready, the high performance, meeting future energy demand reductions, etc. Okay, it's going to require a little bit of change of thinking. And the reason, and again, I'll reiterate, I presented the 2x4 wall with the R10 wall and an R16 outside, is because the ratio is such with the vapor open insulation that sheathing, because there's not a lot of insulation on the inside, benefits from some of the heat inside to help keep it warm, as well as the benefit of having two layers or two giant sweaters on the outside, where that sheathing under, like I said, a minus 15 design temperature would never be below freezing, somewhere around 4 degrees, which is quite good for a dew point within the human comfort zone, the ASHRAE 55 type standard that we're trying to achieve. So there's lots of neat things we can do and expand on. What I'm just showing you here is just a simple way to look at it from a webinar perspective, okay? And so I'm going to change back to the main camera, and I'm going to go and I'm going to reshare my screen and put the slides back on. And at this point, we're at the slope roof to wall interface detailing. I hope you understood exactly what I was getting at here and how this can easily be done. We build skirt roofs already. We put them right on the structure. I did the same thing. I didn't want to change it. I can actually put this on top of insulation, but I didn't want to go down that pathway. That would be like, that's the next version, okay? One step at a time, okay? But you can install it over top of strapping right on it, or it won't have continuous insulation. But I took it this way as a simple example of, we build skirt roofs already. We have stuffed walls already. We do exterior insulation more and more. I chose a vapor open insulation, so I didn't have to worry about ratios as defined in the building code. I don't have time to get into all the nuances of that, but I know that predominantly my vapor drive is going to be inward to the outward direction. I'm going to put materials on my assembly that facilitate that vapor drive. I'm not going to rely on inward drying, because over the life of that structure, that wall is going to get painted numerous times, and every time you paint it, even with latex, in not too long a time, you end up with vapor retardant paint on the inside. So it's not going to dry to the inside either, okay? There's lots of neat things to think about. This is a very simple assembly. I know as far as the costs and that, I think a lot of costs are judged prior to understanding the process. I know the materials are expensive, but all I can do is share that many out there try it. Many report back that they are successful. And it's a good way to build. Do you have to use the mineral wool or anything that I've shown you today? No. You don't have to do anything I said. Nothing. I'm just pointing you out something that Geoff and I sit and think about, and this is what we do. And if for myself, if I had to build something, I would build this myself. I know I could change that roof. Anybody could change that roof without damaging anything. I'd feel comfortable leaving them to their devices. Go ahead, put a new roof on. It's fine. Even behind that roof interface, I got a whole water resistant barrier. I'm feeling comfortable. Okay. And so on that note, if there is no questions.
Yeah, are there any questions from the group around the sloped roof to wall interface? I don't see any in the chat, but feel free to pop them in the chat or raise your hand. All right,
If not,
we're good to move on. Yeah.
We're going to move on then, because we're going to look at a penetration wall, and we're going to look at the air leak test chamber, okay? So we built a penetration wall, okay, because you got to imagine, okay, where does air leakage take place? In the middle of the wall? No. At an interface or penetration? Yeah. Okay, so why not build a wall with a whole bunch of different interfaces in it, or sorry, different penetrations, to see what can I do to seal up each different type of penetration to, well, it's not each type, but a wide variety of different penetrations. And here we put together a hose bib, a line set for a heat pump, low voltage wires for audio. The guy wants the speakers all over the house, and she wants speakers in the garden. Everybody's happy. And PVC pipe, just representative of any kind of pipe coming through. Electrical box, GFI coming outside, maybe a wall vent, could be an HRV. It doesn't matter. There's one thing in common across all of these, and you can see that on the picture on the left. What is it that's common? Doesn't matter what the penetration through your air barrier is. You put an EPDM gasket. And so out of this, okay, simply use a 60 mil unreinforced EPDM membrane. And what we're going to do is, you have some there, Geoff? Please, yes. Okay. So what we're going to do is we're going to do a couple of penetration examples, okay? Geoff's going to make a couple of different gaskets, and we're going to put various things inside them just to show you that the simplicity of it. And then you're going to be, well, that's lovely, but is it actually airtight? Well, we're going to go to the penetration wall, bring that up. We're going to let you have a look at the penetration wall. And you can see on the picture on the right, the hose bib is mounted on its block already. And you got, and imagine those familiar with building, how many actually know where the hose bib's going as it sits there on the wall waiting to get connected, okay? At some point, it gets moved in or out and mounted, okay? Well, at some point, that frost-free connection went through your air and water controls, okay? How does that handled currently to allow adjustability for the mounting process? Well, it's not. What happens is it's out of sight, so it must be okay. Well, it's not okay. Well, we're going to show you that you can put a hose bib in, and does a frost-free bib ever fail? Yeah. Can you change it? Well, we'll show you absolutely you can change it. You can disconnect from the inside, which you'll need to anyway, and you can pull it straight out through your mounting block and pop a new one in. Absolutely no problem. Geoff can demonstrate that right on the wall itself, okay? Same with the PVC pipe, same with electrical, same with low voltage wires. I put in a commercial entry system on a 4-story project not too long ago, had 100 wires coming off the communication panel. Each wire went through a hole in the gasket. Took me only out of 15 minutes. I punched a 10 by 10 grid of holes in a gasket, put each wire through it, pop, 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 and ganged it together, and off it went. Absolutely airtight through the enclosure. Well, I hope it's airtight. I guess we'll find out when Geoff puts it in the test chamber to see what happens, but I'm pretty sure it's going to be non-eventful. If we're lucky, we might see a little whiff of smoke somewhere just for some excitement, but I'm pretty sure it's just going to be airtight. Geoff, make some gaskets. I'm going to move you on over and I'm going to stop my share.
There you go.
You can hear Geoff okay, Jenna?
You can hear me?
We can hear you. Yeah.
What I've got is
Thank you.
our EPDM rubber, incredibly tough. I could pull a truck with a strip of this. I'm going to mark a center point, and in this case, we're going to put a frost-free hose bib in. I'm just going to fold it, crease, fold and crease. Gives me a center point. Mark that. There's a number of ways to make this cut. In this case, this is a punch, a hole punch, a leather punch, sorry, for a hole, or drill. So I'm going to put this in the center of my jig, find that center mark. The lighting's not as good as it was. There you go. There you go. The 3/8 drill bit for this penetration. I want to be undersized, so I've got a 1 inch, 3/4, or in this case, 7/8 with the knuckle. I want to be just undersized. I'm going to drill a 3/8 hole, and I'm not going to push. I'm going to just gently allow that to work through. Done. Small hole, center of my gasket. Now take that, easily pull that over the penetration. Now I have an airtight seal on that pipe penetration. Now this can be taken in and out all day long and maintain a nice tight seal. The other option, which enables the effective stamping, take the same cover, punch a hole. This creates a nice, clean, annular hole. Same idea. Easily pull that over my penetration. And now I have a renewable detail. This creates that continuity of air barrier. I haven't taken 16 pieces of tuck tape and tried to wrap this around my poly on the inside or on my exterior. I can install this gasket directly to my poly with 4 simple pieces of tape, nice and flat and annular on the wall, or I can do it on the exterior, whether it's inboard or outboard, and I can renew that detail at any time and not affect the critical barrier. When I look at the wall, flip over here to the wall, and I can show the penetrations. Picture.
Okay, I'm going to switch over to the other camera. All right, so there's the penetration wall, and this is where we got a bunch of different ones. Remember that the penetration that Geoff did, you can use an aerosol cap, 2.5 inches, perfect for a 4-inch vent. There's a whole formula for doing this, okay? It's very, very simple to do. More and more I'm seeing this on job sites. More and more people are getting below 1 air change per hour. All you need to do is identify and do a reasonable effort to make it airtight. You will be successful.
I'm going to take the camera a little closer here to show you that there's the same hose bib penetration dressed. I've got my starters on there, my strapping, my wood buck that I can run my siding into all the way around. Now, it's not attached currently, but I have that same gasket in the wall. I can remove this hose bib, reinstall. My air barrier has not been affected. Same can go for a simple pipe penetration through the wall. The line set, which is set into place, so I'm not going to pull that one out. Here's a conduit, electrical box. I'm sealed on the inside with an incandescent putty where my wires come through. Weather tight fitting on the back side. I can simply remove that, put that back in, still airtight. Our 4-inch, in this case, a 5-inch head pipe. Pull that out. Simply reinstall with the new fixture. Say the landscaper knocked it off with the Bobcat. Now I need to replace it. I'm still airtight, 100% on my exterior air barrier. Low voltage lines, simply replace the line through the wall. I'm still airtight.
Any questions? Do you think it's airtight?
I think it might be.
Let's find out. We
Well, we
pulled
just had
out
a-
some. Go ahead.
Sorry, we just had someone, sorry, you asked if there were any questions to see the line detail.
The line set detail?
Yeah.
Okay. We're gonna do the smoke test here. The line set detail, it runs through a PVC pipe into an EPDM gasket. You use a putty and a line set tape. Do you have one on the table, Jeff?
No, that was installed. No, I used it.
Okay. You take both of those. Do we have any out in the cabinet? We can just grab
We
quickly.
got some bits back here.
Okay, we got some bits. I'm going to go look for a bit, try to answer that question and perhaps demonstrate in conjunction with the test here of how you can make a line set penetration for heat pump, whatever it might be, airtight.
That's all short. We got the cutting pieces.
Not in the penny box?
I installed that. All those short pieces we had.
All right, folks, as James is looking for that and they're getting the test chamber all ready, I'm just going to let you know that at about 10 to 8, I'm going to run a feedback poll. You'll see it pop up on your screen. So we really, really do appreciate honest feedback, and we look at it all and consider it as we plan out future workshops. So please take the 3 minutes that it requires just to let us know what you thought and what we could have done better. And we really, really do appreciate it.
Very much so.
Nothing up there. Boxes here.
Okay. Just getting the box filled up with smoke, and but can hear me. You can see the penetrations are disappearing. Now we'll spin that around. Well, as you can see, as I back up with the camera a little bit here, and I show you the back of this wall, I'm sorry, and I do apologize, but it's very uneventful. Your low voltage wires, your vents, here's the line set, hose bib, and PVC pipe down the bottom. There's no discernible smoke coming through
One.
on the assembly itself. And one of the things that all I've said from the beginning is, look, you just need to make a reasonable effort of air tightness and you will be successful. And a way to get a reasonable effort of air tightness would be put a gasket for whatever the penetration might be. All you need to do is install a gasket. It's that simple. So even the things we pulled it in, pulled it out, did whatever, you can do that. There's simple formulas to make all of this happen. And air tightness and the idea of going to net zero ready or this one air change where, I can only get 2 air changes. Well, that's not reasonable. Of course you can. It's being done all the time on a very high level. The chamber itself that we use, and it's why, it's one of these things those that are builders, if you wanted to test your own stuff, you can go to Home Depot and pick up a smoke machine and a couple electrical components. This is simply a backer rod, two jarred large backer rods set down with air sealing tape and a couple of bar clamps and some Mylar. This Mylar you can get at the fabric store. Didn't know that, but I know that now. You can buy it by the foot, and they got big sheets of it in different thicknesses. It's crystal clear, as you can see by the picture on the left. It's crystal clear, and it's amazing for doing this kind of testing, and you want to get down and figure out what's going on. The best thing you can do is what we just did tonight. Do a mock-up, okay? Not only will you figure out how to get it done, you get a better understanding of the controls. And what I mean by controls is your building enclosure controls, your heat, air, vapor, okay? Water. How are you going to manage that? And always consider maintenance and renewals, because everything's going to get maintained and renewed. I mean, if you put insulation on the outside of a structure, or similar to what I built, even with a split insulated wall, regardless of what you do, to get water penetration through that assembly is very, very difficult. I have had the pleasure of testing these wall assemblies with extreme pressures and rain racks. I have yet to get water through an exterior insulated wall assembly to the wall. If you have air tightness and multiple layers staggered, it's pretty impenetrable. And when you do things with the rain screen, even though many places in the province don't require rain screen based on the heating degree days and the moisture index, regardless of what it says, there's a direct benefit to having that rain screen. There are cases where we have issues and failures of newer buildings, 5 years old, exceptional air tightness, where all the insulation's inside the wall, but there's no rain screen and the cladding's right on the sheathing. Well, you got to look at it this way. At least I look at it this way. You don't have to look at it anyway, but I'm going to look at it this way. It says, I know that air leakage is not zero. And we all know that. It's never going to be zero. But I know that if I have air and it's 20 degrees Celsius and it's 40% humidity, I know the dew point for that air is about 6 degrees. So any surface that touches below 6 degrees, and I know I have air leakage through my walls. I know that. It just kind of happens to some. And I know that if I put insulation inside the wall, the sheeting is going to be cold, because if I don't have a sweater on in the winter and I go out in the Kootenays here, I'm going to be pretty cold. So it's pretty cold. And that's why I wear all my environmental separation on the outside. Mother Nature does put the fur on the animals on the outside. I don't know. Maybe it kind of makes some sense there. I'm not sure. But putting the controls on the inside, okay, results in a cold sheeting wall. Can that work? I suppose. Are there a lot of variables? Well, yes. What's the ventilation? What's the interior loading? Okay, what's the climate zone? What's the amount of air leakage? Is it general air leakage or is it concentrated air leakage? Will it dry out sufficient or equal and have a balanced wetting and drying? But I think to myself, well, why am I even worried about that when I can build a wall that's not going to get wet in the first place? By either exterior water load or interior water load, by keeping the sheeting above dew point. And so that's what we've done to take you through that here. It's 7:44. Jenny, you wanted them to fill out some paperwork or something?
Oh, no, that's okay. We can do that while we're going through this discussion. We do have a couple questions still in the chat.
Excellent.
And I know we're gonna look at that line detailing too.
Well, I don't have the piece I can do the line detailing. What I can do is I can open up my. Hey? Oh, Geoff does have it. Okay.
Yeah, we could see Geoff busy back there. I figured he was getting it ready.
I was too busy looking at the other monitor. I didn't see him in the back there. Well, that's fantastic. And so that person that asked the line set question, I will take you through the process of how you can practically, with everyday materials, seal up a bunch of foam wrapped coppers, a condensation line, a power line running through a pipe, through a wall, and make it airtight, which we just demonstrated. And that can be done very, very quickly and with virtually minimal costs with simple materials. Okay. Are you ready to do that, Geoff? I'm going to switch over to the other camera and I'm going to stop sharing. All right. So we're back over. Geoff, he's resorts to grade 4 and he's making little wormies out of plasticine, I guess. That's what that looks like.
Here's our typical line sets, our 2 feeds, our controls, our condensate line. We've got all those clamped. We're going to need to put all these into one bundle to make them continuous and transfer through to the rest of our assembly. So in this case, I'm using duct seal. just a brick, a putty, and I'll see that. Making worms. So you can see I've already wrapped a couple of worms around my penetrations. And I'm doing it all at the same elevation on the lines. I'm going to wrap these worms around. So now I've transferred, you can see here, there's putty in between each line. Now I've got a consistent bead of putty that I'm going to press it all together nice and thoroughly. Because I've done it all in one plane, I haven't put them all into, they're going to integrate together. And what I've done is now plugged off any ports. I've got it. I think. Yeah. Well, I've got some Sega. I've plugged off every port in between. You want red tape?
We can take it off after that.
Yeah. Now I've connected all of these components, have now become one component through that line of the putty. Now I'm just going to consolidate them. In this case, I normally would use a high performance tape with a heavy acrylic backing on it. In this case, I want to be able to take it apart again. So I'm just going to use the tuck tape because now I've made the entire assembly intimate. And then I'll grab my PVC, hold on. I had a PVC pipe going through my wall as we do in that mock-up. When I insert this in there, I align because now this PVC pipe is going to be gripped by my gasket on the wall as we saw in the previous. So now that I've got all of those components consolidated, so I want to keep it elevated in the center of this opening. So in order to do that, I'm going to take some backing rod, foam backing rod, and I'm going to insert that around the pipe to create compression and center my assembly in the center of the pipe. So now I've got a nice gasketed base. I've got my taped finish. Oh, let's move back this. Tape finish back this way. See, that center of that tape is where my line of my air sealing is. When I insert into the pipe, the final step, I want to now connect. I've connected each one of these components together into one, transferred it to the tape. I've now got to transfer it to the pipe because the gasket, the rubber gasket, is going to transfer it to the wall. So that I make a connection. So in this case, we would caulk this perimeter all the way around. And now I have intimacy from each individual line through the putty, through the tape, through the sealant, to the pipe, pipe to gasket, gasket to my exterior air barrier. And now I have a robust, airtight penetration through the wall.
So I saw a question with Derek to everyone about a leakage between the foam. Part of what you have to get, and we showed is, if you put the putty and you squeeze it together and you lancet tape them together, if you look at the end of what Daryl, I believe the name was talking about is when you actually look, and I'm going to change my camera now. When you actually look at the end, you can see the gap between the foam. When I have this here, and I actually squeeze it with my line set tape and my putty, I predominantly close that off, which became quite evident when you saw the smoke test. And obviously, we've tested this numerous times. To answer your question, can I get a little bit of smoke might travel through there? Yes, you bet. What I have to understand is, will that amount to anything? No. The air tightness that you can achieve overall, and I'll say it again, by recognizing and making a reasonable attempt at an airtight approach, typically involving a rubber gasket and perhaps some putty and common sense or whatever that might be, you will always get exceptional air tightness and reduced energy demand. But please know that if you're familiar with the line sets, Daryl or whomever is looking at them, if you take the foam, you're absolutely right. that foam is not intimate to that copper pipe. But as soon as you put putty between there, you squeeze it together and you line set tape it, you must in your mind imagine, yeah, I've greatly reduced that. Yes, you have. And that was demonstrated. I hope that helps.
Great. Thanks, James. And we do, just recognizing we only have just under 10 minutes left, and there have been some questions coming through. I'm just going to start from the top here. Sam asked if you can touch on rigid foam versus mineral wool for performance and cost differences for exterior installation based on the climate zone in the Kootenays.
Okay. So that's a loaded question, and you only give me 10 minutes. Okay.
Well, we have other questions, so maybe a couple minutes.
I'm going to try to be as simple and clear as possible. If you're going to do a split insulated wall like I demonstrated to you, I know the Part 9 of the building code gives you insulation ratios that apparently will work if you think drying somewhere around a perm makes sense, okay? Well, it doesn't make any sense because you have a vapor open assembly and it wants to dry itself out, okay? If you want to put foam on a wall, you want to put the majority of it on the outside, or at least enough that brings the dew point of that wall assembly outboard of the sheathing. The last thing you want to do is have that sheathing get condensation or moisture buildup of any kind, because it's not going to dry outward and it's not going to dry inward. I don't care what snake oil everybody tries to tell you, stuff like that, okay? Is if you paint a wall with latex, 3 to 8 perms, whatever it might be, depending on cleanability, et cetera, okay? Over the life of the building, it's going to get several coats of paint. Over time, it's going to have a vapor closed paint on there, a vapor barrier paint, and the drying inside is going to be restricted, okay? And so if I have to use foam, a nice rule of thumb, if I was in the Kootenays, I'd do 1/3, 2/3, okay? Where that's why I like a 2x4 wall, because if I want to bump up my R value and I want to put a little 2x4 wall in front of, say, my foam or whatever, I get the bump. But what I also get is I get the benefit of some heat loss, because the definition of insulation is resistance to heat flow. And if I put a 2x4 wall, will more heat go through a 2x4 wall or 2x6 wall? Well, clearly the 2x4 wall. Therefore, I'm getting some warming of the sheathing, which helps reduce my condensation. The reason I don't want to talk about cost, I find that builders have been doing it with all different products, and cost becomes a function of process. What I tried to talk about today was the process of diversifying your crews, splitting them up. I mean, if the tools don't zing, the register don't ring, okay? I see too much wasted movement, effort, times, and worrying about costs and all the rest of it. We need to move forward. Can you do foam? Yes, you can. Would I suggest following the ratios in the code? No. It's minimum. It's one step above illegal. That's the building code, right? So you can go to that level if you like to. I don't have a problem with that. You do whatever you want. Myself, if I was going to do a foam wall, I look at fire resilience, okay? I look at the ratio, and I'll put most of it in the outside. And the reason I like the mineral wool or any vapor open insulation on a split is because, like I said, my window is in the middle of thermal plane by default. So many things falls right into play. I put the insulation on the outside. It's the right thing to do. Whether you want to use foam or mineral wool, it is a function of your cost. If you're going to choose the foam, just heavyweight it to the ratio to the outside. Don't follow the Part 9 ratios that are listed there, where I could put 2 inches on the outside because, well, it's just under a perm or whatever it might be. I know that up to 3 inches of EPS, at 3 inches, it's a perm. One perm is 57.40 nanograms, and nanograms means billionth of a gram. Your drying potential is really, really slow. And if you've got sheathing that's getting air leakage and condensation, I like to see a balance between wetting and drying. That was the first thing that was ever taught to me. James, things can get wet, and it's very important to understand that you need to maintain a balance between wetting and drying. Okay, boss. I mean, I'm a new guy, and that's funny, but it was one of those things that just stuck in my mind. There's an expression, stuff happens, okay? And things might get wet, but can they dry? And will they dry over time and meet the duration of durability of that enclosure or the largest investment that we're going to build and construct? Is it going to survive climate change? Is it going to survive the forest fire? Is it going to survive all of these atmospheric rivers, all the crap that we got going through right now? We should be building on the side of common sense, where if I got drying outward, let it dry outward. Don't put something on the outside like foam that slows that down. Unless I move my dew point outside, then I don't care. I hope that answers. God,
Yeah, great. Thank you, James. Okay, we have and thanks for keeping that under 10 minutes because we still have a couple more questions here. And folks, just a reminder, I did start that feedback poll if you have a minute there to fill it out. This was just a comment when you were looking at the penetration wall. The low voltage is a little tough if you can't see the holes it came out of. So any response to that?
What do you mean the holes that came out? To see what?
Just says that low voltage is a little tough if you can't see the holes it came out of.
So if you're doing low voltage wires and that, and you're doing a punch, say a 1/8 punch or whatever that might be, I'm not sure exactly the intent of your question, but I know that on a 60 mil rubber, I have not found any wire whatsoever that I can't identify where the hole is. And when I'm doing this here, what I do is I'll take the wire, okay? I'll say, okay, I'll take the wire. And I look at the end of the wire and say, hello, wire. You look, and I'll take my drill bit and go, hello, drill bit. That drill bit looks about half the size of the wire. I think I'm going to put you two together, okay? And so I'll drill a hole like Geoff showed you, or I'll take my leather punches, which I have also, and I'll punch a hole about half the diameter of the wire, and I'll pop that in. You'll see a little micro turn on it. If I pop that out, I can still see the hole. I've always seen a hole. The point I'm getting at, if I pop it in there, why am I taking it out again? If I have to take it out, it's not hard to find because all you can do is push in the rubber and you'll feel where the hole is. Because it's flexible. I can rub my hand, oh, there it is. Okay, pop it in. So not too difficult at all. Hope that helped. I wasn't sure of the intent of the question.
Okay, well, let us know if there's a follow-up there. I'm just going to try to get through the questions that are here. With a taped outside barrier, how can liquid water escape? I make sure to do a good job lapping my WRB, but I feel that if I tape horizontally, I will, sorry, I got to move my mouse here. I will trap liquid water. That is why I've stayed with interior air barrier. All
right, so if you got water behind that, you've already failed. I'm sorry, but you've already failed because you got gaps in your plywood. You got it. See, the outside barrier is what the code calls, and we all call the last line of defense, okay? If water gets past that, you've failed, okay? That has nothing to do with where you put your air barrier, okay? If you lap and shingle, you won't have any issue. And so you hold that thought for a moment. So, okay, if I tape that horizontal, am I suggesting that water is going to run down the plywood, jump over the end lap above it, and come out between that membrane? It's not going to happen. It won't happen, okay? And so I'm looking at saying, okay, well, if it's the last line of defense, what can I do in front of it, right? And so, well, let's see, if I put that on, make it air barrier, tape everything, I've got this water resistive shell over the organics, which can't get wet. If water gets there, you fail. You can't get wet. And then I say to myself, well, I want to keep up the sheathing to keep it warm, so I can put a little insulation. So now that water that you're worried about has to get through the insulation too. Isn't it funny how everything you do to make the wall better by moving controls to the outside actually by order of magnitude makes the performance of that wall even better? And so not only do I get a more airtight wall by putting insulation on the outside, I get a more water resistant assembly by putting it on the outside, or some of it or most of it or whatever I can on the outside by the right type, of course. Then I get all these benefits. Where if you do an interior air barrier, I'm going to ask a simple question that I ask builders all the time, okay? What are you doing behind the bathtub? Don't know. Hard to do. What are you doing in the any basement that has a tub? And if you get any condensation on a question that builds up anywhere, all that is highly vapor open. The whole idea of putting that type of membrane on, like Tyvek, is extremely vapor open. If I put a wet cloth in a Tyvek bag and taped it up and hung it in my shop, we'd be dry in a day or two, okay? Like, I'm not worried about that. That's the whole idea of it, okay? What you don't want to do if you're getting condensation or build up, as a question that popped up in chat here, is what you don't want to do is put a vapor closed membrane or something that slows it down, because which way is it going to dry? It's going to dry outward. And so you want to make sure that it can't continue to do so. And try to follow the building science fundamentals and don't get caught up in too much of the myths of, a lot of times, I'm fairly old. I used to have hair and stuff like that. And I've been to a couple of rodeos along the way, and I've messed up lots of buildings in my youth. So when I think back, oh crap, I didn't have a clue what I was doing. Well, that's okay. We all live and learn together, right? But imagine moving forward. I hear, oh, I got to cut the poly so the building can breathe. Well, that's fundamentally backward. Okay. The house breathes by way of mechanical system. We're trying to manage uncontrolled air leakage so we can solve the mechanical system so we can reduce energy demand. And if this type of year and you got heat inside and moisture building up on the Tyvek and all the rest of it, I would have to say, I don't really care. It's going to dry up.
All right, folks, I just recognize we're at time. There are a few more questions, James. I'm not sure if you have time to stick on. But we can also gather the questions I can record them and get them back to you, and we can respond via email. Whichever works best.
Tyvek is vapor open, very vapor open. Okay. There are other synthetic membranes out there, the Segas and all these that they're ridiculous. Vapor Shield at 50 perms. Okay. They're 4 or 5 times more vapor open than Tyvek. Okay. Part of the deal is if you're building and you're dealing with moisture load, make sure you choose the right materials that can facilitate that drying mechanism, okay? And putting a vapor open or sheathing membrane on the outside when you have insulation on the inside is not a problem. But what you want to do is put insulation on the outside. That just takes away so many problems.
Great. And then just one last question here. If you used an air/vapor barrier like Blueskin in place of the Tyvek on the outside of the building, would you be able to skip the vapor barrier on the inside of the building with this type of exterior insulation setup? So
a 2-part answer to that. First part is yes, you don't need a vapor barrier on the inside because you already put it on the outside. Second part to that is if I put peel stick on the outside, my vapor control goes where? It goes on the warm side of my insulation. Therefore, by default, I trust you're putting insulation on the outside of the building then you won't have a problem. If you put Blueskin on the outside and you insulate inside, on a quiet night, you'll hear that building deteriorate. It's not how you do that.
Okay, great. Well, thanks so much, James and Geoff. I know he can't hear us, but big thank you to Geoff as well. And thanks for all of you on the call. That was wonderful.
Yeah, that's amazing.
I really, really appreciate all the insights and the opportunity to see these concepts put into practice with those mock-ups.
Yeah, and thank you. And thanks, everybody. It was an honor to do this. I just came back to the Kootenays. I grew up here as a kid, and I went to the coast, and the coast made me crazy. You can tell I'm crazy, but I'm hoping to get sane again and come back to the Kootenays. But anyway, we put together this studio to do exactly this kind of thing so we could have open discussions, okay? And so if we do another one together or you attend another one, okay, please talk. Please ask questions, okay? It's wonderful to talk back and forth because together we learn together, okay? I didn't say I know everything. I know a few things. I can analyze and deduce things, and together we can solve things. But I need your participation. We all need to work together. So on that note, so I hope you enjoyed our little time at the Meadow Creek Studio. We had a lot of fun doing it. Thank you, Jenna, for the opportunity. And with that, I'm going to take my hat off so I can look at the glare, and I'm going to go have some dinner. So all of you, good night to you all.
Great. Thanks, James. Bye, everyone.
Thank you. Bye-bye.